That's like impossible to read. Okay. Let's see. Okay. All right. This is stuff that I hope you learn. All right. So here's how we're going to do the grades. 5% attendance and class participation. So I'll show you in a moment, but from your phones, I'll run this thing called the online poll, and then you'll log in, and then you'll respond to polling questions using your phone. It's kind of like using the clicker, except you don't have to buy a clicker. Maybe some of you already own the clicker, and you're disappointed that I'm not making use of this $60 remote control that you bought for a different class. But if you don't have a clicker, you don't have to buy one. Your phone is more powerful than a clicker, and it should work, okay? So anyway, in class, I'll put up some questions and stuff for you to answer. You'll take some quizzes during your discussion section, okay? So Yu-Hao is going to be your TA, and he'll run some quizzes. We've also got some lab assignments, and Yu-Hao will run those, and those will so quizzes will generally be on Mondays, and the labs will generally be on Wednesdays. And it says 5 lab assignments, but I think I'm going to cut that down to 4, okay? And I'll just give everyone 100% for the 5th lab, okay? So that's 2 free points. All right, and then homework 10%, and then 30% midterm, 30% final exam, okay? And those will be in class on these days. Make sure you come to class. It's summer session, and so you really should not miss class at all. I mean, during regular school, you shouldn't miss class, but it's during summer, it's like really important because there's only 6 weeks and there's only 2 sessions per week. So we've got 12 sessions. And then if 2 of those are taken up by tests, then we really only have 10 days of lecture. And that's like basically an entire week per lecture. Okay. So if you miss one, it's like, it's not a good thing. Okay. Anyway, make sure you come to class on the days of the midterm and final, okay? Letter grades, I don't curve grades, okay? So it's just straight scale. I try to do my best in terms of writing exams that are fair and measure the content of the course. I don't like curving grades because I feel like students have to then compete against one another, and I'm not a fan of that idea. Only with the exception of the A+, okay? With the A+, the top 5% of students will get the A+, but that's the only one that's based on performance relative to your peers, okay? We've got a textbook that you should get. The 2nd edition is probably fine, but they always change up the homework problems, and you'll have to do that, okay? The calculator, you'll need a calculator, whether it's a graphing calculator or scientific calculator, you'll need one. I can't let you use your phones on an exam. We've talked about quizzes, and these are the days for those, and then again here are the days for the exams, and then and this is what we'll do for the labs, and then we'll just skip lab 5, okay? Any questions on that stuff? Yes?
So you said the 2nd edition is 12, is it fine?
So the honest truth is I haven't even looked at the 3rd edition, okay? So I don't even know what, like, I guess it's possible that they made some dramatic change to the 3rd edition, but that's generally not what happens with textbook publishers. They often just hire someone to change up the homework problems so that it makes students' lives inconvenient if they buy the older edition, okay? And it's, I don't know, I shouldn't be bashing the textbook companies, but maybe I feel like, okay, anyway, so generally they make cosmetic changes to the content, changes to the homework, to inconvenience your lives in case you get the older edition. And I don't know, that's what we have going on right now. I think what I'll probably do is I'll just release homework assignments that are good for both the second and the third edition, and you can do either set of homework. Because actually, to be honest, I'm not even gonna look at your homework. The homework, you guys are laughing, but really, like, I don't get any pleasure out of knowing you do your homework, okay? I love my job. I love teaching. I love explaining stuff and getting you guys to learn. And I do think homework is one of the best ways to solidify your learning. And so I definitely encourage everybody to do the homework. But I don't really, if you don't want to do your homework, you know, that's your bad, okay? So I'm going to assign the homework. I'm not even going to collect it. I'll post the answers to the homework, and it'll be up to you to kind of check the answers and make sure you did it correctly, okay? I'm not even going to collect it. So this 10% homework is really just 10% free points. So I'll give everybody 100% for the homework, because there's a little bit of trust, all right? You guys are here. You guys got to UCLA because you did your homework in high school, right? So I'm going to trust you have maintained those habits and will still do your homework here at UCLA, okay? But I'm not going to check, okay? And that said, sometimes people don't do their homework, and then they come to me in office hours the week before the final and say, I'm doing really bad. What can I do to pass? And I'll say, well, how have you been doing on the homework? And I'll ask to see your homework notebook or your homework assignments. And if you're going to tell me at that time that you haven't done your homework, you're not going to have much sympathy, that you have sympathy from me, okay? If you have been doing your homework and you have tried hard, then I will work closely with you to help you improve. But if you're going to tell me that you haven't done your homework, then I'm going to say, well, you know, what'd you expect? Okay, it's just like playing a sport, practicing an instrument, trying to work out. If you don't practice, right? If you played a sport in high school, I imagine you practice every single day during the season, and that's because that's how we get better at stuff, right? Is by practicing and pushing ourselves beyond just what we're currently capable of. And I think the homework's a great way to do that, okay? But it's up to you, right? It's okay. Makeup policy, if you miss a quiz, you got to make it up within 7 days. Contact me or the TA to kind of schedule a makeup. Attendance and participation will be done via the online poll. I'm assuming you guys all have UCLA logins, even those of the freshmen who are just entering. I imagine you guys have UCLA logins. And so we can try this out right now. Go to onlinepoll.ucla.edu and log in there. And you'll have to do your two-factor authentication with Duo and get logged in. And then I will create a poll here. Okay, stats 10, so I'm going to click. Okay, and all right, so I think a question should appear under, like when you log in, this question should appear. There's no question, okay? So the way it's gonna work is, like I would write a question over here, and it would be like question 1. All right, and you can just say, you know, what is the first letter, right? Oh dear, something just happened. Okay, so what is the first letter of the alphabet? Okay, and then your answer choices are A, B, C, D, or E, okay? And then so I guess, I don't know what I'm doing here. All right, so these are your possible answer choices, and you will answer here, right? And then we can take a look at, okay, all of you, 30 out of 30 of you are getting it correct. Anyway, so anyway, there should be more of you responding. It's not loading? Did you just add the class recently? No? Okay. All right, we'll have to check what's going on. If you're enrolled in the class, it should appear in the thing. It's not. Okay. A bunch of people are shaking their heads. Okay, well, I'll contact the people who run this website to see if they can just update their rosters and whatnot. And it should be good to go, I hope, by Wednesday. Today's won't really count for anything, but here we go. Okay. Anyway, you should be able. Are you at least able to log into the website? Yeah. Okay, but my poll is just not showing up for you. Yeah. Okay. It says you don't have permission. Yeah. Okay. All right. Okay. Well, I hope we get it fixed. Okay. All right. Not your fault though. Okay. So anyway, that's kind of how it's going to work. And everybody else was able to log in. Okay, 56 people were able to log in. All right, let me see if there's anything else I need to say about the stuff. Okay, academic integrity. Be honest, don't cheat. For exams, I'll probably have assigned seating for exams. I'll send out a seating chart like the night or two before. Your desks, are they numbered or are they not numbered? The seats... There's no numbers? Okay. All right. I'm gonna just have to make some arbitrary numbering system then. Okay. The university has a lot of resources. I hope nobody experiences any kind of traumatic event. But the university has a bunch of resources available for anybody experiencing any kind of issues, whether it be sexual harassment, sexual violence, gender discrimination, and if you experience anything or issues with mental health, my encouragement is that you seek help and guidance as soon as possible. And I know CAPS is often understaffed, or just like their appointments are fully scheduled and things like that. But the university has made efforts to try to offer resources within their their constraints and stuff to you guys, and so please make sure you use those if you need them. If you have a disability, I imagine you are aware of the Center for Accessible Education, but if you're not, the university has resources and is willing to make accommodations to help you there as well. And so that information is listed in the syllabus as well. Okay. And just some extra stuff in the syllabus that we probably don't really need to cover at the moment. I do want to say a little bit about mental health, and just I'll say this throughout the quarter, and students never like hearing this. Well, I don't know about never like hearing this, but you know, your mental health and your personal well-being is much more important than any grade that you can get in any course, okay? And so don't allow like the pressure to do well academically in some class that to have an impact on how you view yourself, okay? I know it feels good to get good grades, and you guys are all here because throughout your high school lives you worked hard to get good grades, okay? That's kind of the population that we're dealing with now that you guys are all at UCLA. And so I know that in high school, all of you worked hard to get good grades, and so there's an internal drive in you to want to get good grades, and I understand that because I was very much that way as well when I was a high school student. But the flip side of that, or the downside of that, is that tying your identity or your self-worth to your grades is a dangerous place to be in. Okay, because at UCLA, it's a lot harder to get those good grades, and whereas failing a class in high school may have been something that was unfathomable to you, failing a class at UCLA is not an impossible thing. And whether it's this class or a different class or whatever it may be, you know, a poor academic performance should never reflects who we are as a person, and I don't want it to affect who you are as far as your mental and emotional well-being goes. Get sleep. Getting sleep and being well rested is, I think, offers a good first line of defense towards some mental health issues, and of course, not to say that sleeping is going to cure everything or fix everything, but I do think that that is a good practice to do. And then, of course, make use of any resources that we have there. Okay. Are there any questions before we dive into the course content? We're all good? Yes.
Is there a library reserved for the textbook?
I don't know. I have not made a request at the library. I imagine the library somewhere has the textbook somewhere. I imagine if there are unethical ways to get the textbook, I imagine, you know, you can also share textbooks with, like a real textbook with a friend or something. I don't know. Yeah, and considering I think the 3rd edition just came out and is the thing being stocked, I imagine the libraries don't have the 3rd edition yet. Okay, I don't even have the 3rd edition. I think I have to walk down to the bookstore and buy it. So, okay, so we'll begin. All right. Oh, okay. So I will post this, and I'm going to start here. with this. I'll post this on the CCLE website. And this is basically, you can't read that. How do I? Is this not? Okay, here we go. All right. This is what I feel to be the most important stuff of the class. Okay, so I'm going to go ahead and tell you that at the end of the course, this is what I want you to walk away with. Okay, we're going to spend 6 weeks going over the stuff in the textbook. I expect to get through chapter 9 in the textbook, which covers inference for means and something called the t-test. And there's going to be math and numbers and stuff that goes along the way. You're going to have to do some calculations. You're going to have to use your calculator. You're going to have to look up numbers in a table and stuff. Okay? But as far as statistics goes, when you graduate from UCLA and you go off on your career, and 10 years down the road, maybe you'll have a niece or nephew that says they're taking statistics in college. And I hope you'll say, oh, I love statistics. I had a great statistics class when I went to UCLA, and this is what I learned, okay? And I hope you'll remember stuff from this class. And if there's anything that I want you to learn, it's gonna be these 5 bullet points or 5 items, okay? And I'll go through them with you, and then and we'll go through that. The rest, where we're doing the numbers and the calculations by hand, I will not be upset if you forget how to do that 10 years from now, okay? I won't even be upset if you forget how to do it next quarter, okay? But I will be sad if you don't remember these 5 points. So I'm gonna bring up the 5 points now, and I'll keep bringing them up throughout the quarter. And these are the kind of the 5 points that I want you guys to really internalize as what you've learned, what you will learn, and what you have learned in this class. And we'll cover all of this stuff and the calculations and the things in between. Okay. All right. So number 1 is that we can draw conclusions from data. Okay. That's like the biggest idea that statistics presents. Okay, is that we can draw conclusions from data. All right. And here's the important thing that we have to remember about statistics is that the kinds of conclusions we can draw depends on how we obtain the data, okay? You have a lot of people who are data skeptics, okay? And that's because I don't think they've understood this second point, that the kind of conclusions we can make depends on how we obtain the data. People will say stuff like, oh, with statistics, you can say anything you want, okay? That's not true. You can't just say anything you want, okay? It is true that this data says this thing, and this data over here says something else, okay? And it's because those two things were obtained different ways, all right? So, so these are kind of the big divisions, is that if we want to make a conclusion about cause and effect, if we want to say this medication makes this effect, or changing this thing in your diet will have this effect on your health, if we want to do that, that data needs to come from an experiment with random assignment, okay? If we want our conclusions to generalize to the population, meaning that even though we observed only, even though we only talked to 500 people, if we want those things to generalize to the population, so, you know, presidential candidates are already going out there campaigning, and if you're going to see a lot of polling stuff, right? And if we want the results of the poll to be able to predict what's going to happen in the general election, okay, we can only generalize our conclusions if the data we have is representative of the population, okay? So people believe that was a major issue in the 2016 election, where the polls all said one thing and then the general election result was something different. People are going back and looking at that data, and they're coming to the conclusion that it was not representative of the population, okay? And so these are kind of the big ideas. And lastly, it is nearly impossible to draw any kind of conclusion from anecdotal evidence. And so we'll talk about what anecdotal evidence is, but these are kind of the things where it's like, oh, you know, I know I have a friend whose aunt did this with this oil, essential oil stuff, and she sniffed it, and suddenly all of these things happened, okay? I'm not going to deny that this story is true, okay? We can believe that this story is true. However, trying to draw a conclusion and say this thing that she did is the reason for this thing happening in her life, that's much harder to kind of establish, okay? It might be the fact that, yes, indeed, she did this, and yes, indeed, this other thing happened in her life, but to make the connection that this was causing this, I don't know if we can do that, okay? So this is point number one. We can draw conclusions from data, but what we can do, that's harder, okay? The other thing is that we can only make conclusions about populations, okay? And we can only make predictions about what happens on average, all right? So statistics is always about kind of just on average this should happen. In the general population, this is kind of what we think is going on, okay? We cannot, it's like impossible to make any kind of predictions about one individual, okay? So if we want to try to predict like, you know, what will happen when I flip the coin next, okay? That's impossible, okay? So about an individual observation, it's impossible to make really good predictions there, okay? We can really only do stuff about that, right? All right, and this is, we're gonna spend a lot of time on this idea here, right? That we might observe an association between variables in our data, okay? We might see that changing the diet over here has an effect on some health outcome, like blood pressure, right? So we might see an association between diet and blood pressure in our data, okay? However, that does not necessarily mean that changes in diet and blood pressure are actually connected in any kind of meaningful way in the real world, okay? And it's very possible that what we saw in our data, that changing the diet and the resulting changes in the blood pressure, that could have just been a random fluke, okay? It could have just been possible that we just so happened to change the diet for these people, and just by random chance, okay, because random things happen, stuff happened with the blood pressure over here, okay? And so, so there could be a relationship. It could also be a random fluke, okay? And so we're going to spend some time in probability to understand what types of random flukes are likely, what types of random flukes are unlikely. And the last conclusion is that the statistical tools that we're going to cover, the confidence interval, the z-test for proportions, and the t-test for means, and you'll learn how to do this stuff by hand, you know, will give us a numeric value that will allow us to decide if kind of the association we see in our data, if that is likely to be from random chance or if it's unlikely to be from random chance, and then make some kind of conclusion, okay? All of this stuff here is kind of just explaining the link to go from the probability to the conclusion, okay? I will not be upset if you forget all of this stuff, okay? But I guess I might as well talk about it, because this kind of lays out how we'll get through the class. So learning probability is going to be chapter 4. The rules of probability lead to something called the central limit theorem. That's chapter 5. And that creates a sampling distribution, which is, I think, chapters, I have to double check, chapters 5 and 6. And then we can use this sampling distribution, which is normal, and make some kind of conclusions, and that will be chapters 7, 8, and 9, okay? And so there is a logical thought, or a logical connection between all of these things, jumping from point 4 to point 5, so you don't have to memorize this. But these are the big points, okay? Number one, we'll talk about this stuff today, and then we'll probably number 1 and 2, I don't know, okay, today, and then we'll start talking about 3, 4, and 5 later on in the course, okay? So I'm gonna refer back to this. I'll post this up now, and this is what I want you to learn and remember 10 years down the road, okay? When people ask you about statistics, I hope you'll remember at least these major points. Okay, so let's start writing stuff. All right, so I like to write notes by hand up on the screen. Sometimes I use slides, but in this class I find myself wanting to write by hand. It slows me down a little bit, but I think that's a good thing, okay? Everybody learns a little bit differently, so just because I'm writing stuff on the screen doesn't mean you have to write the exact same thing in your notebook, okay? You can, all right? And if that helps you learn better, go ahead. If it's better for you to just sit back and watch and listen, also fine. Everything I put up on my screen here, I'll save and I'll post online for you guys as well, okay? All right, so anyway, here we are in Intro Stats, and this is very exciting. And like I said, I love this class. If you'll allow me to be a little sappy and cheesy, this class literally changed my life in terms of, does this work? Yes, all right. When I took Intro Stats as an undergraduate student, it changed my life. I did not attend UCLA for undergrad. I wish I did, but I actually attended the small engineering school in Michigan, and I studied engineering there, and I loved engineering, but when I took statistics, I fell in love with the subject, and long story short, after taking statistics, my Intro Stats class there, I took as many classes as the university offered, which was not many. They didn't have a statistics department. I think there was like 3 classes, so I took them all. And then I worked for a little bit as an engineer, and then I decided I want to go back to grad school and study statistics, and so I came to UCLA. I got my PhD in statistics here, and then I got the dream job, the best job I could possibly imagine, which is being here teaching you guys statistics, and so yeah, this wouldn't have happened if I didn't take an Intro Stats class many years ago. So anyway, I don't expect all of you to become statistics professors, but I do hope at least you'll gain an appreciation for the subject. Okay, so I think I covered why we study statistics, right? Okay, and that is that statistics allow the subject statistics allows us to make conclusions from data. Okay. And by being able to make conclusions from data, this will help us to understand things in the world, okay? All right, and so progress in science happens by asking questions and seeking their answers. That's what I say, okay? So progress in science happens when we ask questions and seek their answers, right? And so every question we ask in science has some relevant population. Okay, and a population, okay, population is defined as kind of everyone or everything that's relevant to answering this question, okay? Okay, so for example, if there's a pharmaceutical company developing a drug that could be a possible treatment for some disease, let's say, I don't know, lung cancer or something, then the population would be everyone or everything relevant to answering this question. So if the question is, is this drug useful in fighting lung cancer, then the population would be everyone that has lung cancer, okay? Because we're not interested if the drug is helpful on healthy people, okay? We only want to know if it's helpful on people who are currently suffering from lung cancer. So, so that's what we've got, all right? I don't know if I need to write that down. However, the issue is that in general, the population is too big to be studied directly or too difficult to track down, okay? The population is too big or too difficult to find, too big or too difficult to find, and we cannot study the population directly. Okay, so again, going back to talking about lung cancer and people with lung cancer, we don't even know who has lung cancer. There's a lot of people who have lung cancer that haven't gone to the doctor and aren't even aware of that they have lung cancer, okay? And so we cannot even study this population directly because we don't even know who's in it, okay? And so anyway, when we ask a question, there's a relevant population, okay? At least some hypothetical relevant population, but we often don't have direct access to it, okay? You can ask just a population that's very well defined, such as US voters, okay? So there's a definition, okay? And those are US citizens who are 18 years or older. Those all count as US voters. But that population is often too big for us to ask directly, okay? There's probably, something 100 millions of people, okay, living in the US and also living internationally. And they're too big, there's just too many people for us to ask directly, right? And so when people conduct polling, they know that they cannot ask every single US voter. And so they just, they survey, I don't know, a couple hundred people, okay? And then they're hoping that these couple hundred people are representative of the entire population, okay? So that's what we do, okay? So instead of studying the population directly, we take a selection of people or subjects and study the selection. Okay, and this group is called a sample. Okay, and so the kind of the picture here is this blob here represents the population, and this thing is too big for direct study. Okay, and so from the population we just take a tiny little piece, okay? We take a tiny little piece, we blow it up. This is our sample. Not blow it up, but we observe the sample, okay, and we observe this thing. Okay, and based on the sample, we try to make conclusions about the population. And this is called inference. Okay. Okay, so, you know, it's like, again, maybe you're curious if a drug is effective. You give the drug to a few people, and you give a placebo to other people. So you've got two groups, you know, those receiving the drug, those receiving the placebo. And let's say 40% of the people in the drug group improve, and 30% in the placebo group improve, okay? Does that then mean that the drug is more effective than placebo? What do you guys think? Maybe, maybe not, I don't know, okay? What if it's a little bit more extreme? So you give the drug to some people, you give the placebo to some other people, and this is random assignment, and we'll talk about, you know, how to set up an experiment properly. And let's say 70% in the drug group improve and only 20% in the placebo group improve. Does this mean that the drug group is more effective, that the drug is more effective than placebo? Okay, so some of you are shaking your head and some of you aren't sure. Okay, and so, you know, 70% versus 20% sure seems like a huge difference, right? If this is truly the rate of effectiveness, then that would be amazing if that was the true rate in the population. But I didn't tell you how big my sample was, okay? If I only gave it to like 5 people or 10 people or something like that, you know, the difference is may or may not be reflective. Now, if I gave it to 1,000 people, then yes, that difference between 70% and 20% would be dramatic and amazing, and we could market this drug very effectively. But again, if you only gave it to a handful of people, then maybe not, okay? And so statistics, the subject, will help us decide at what point is this difference important or significant, okay? All right, and so anytime we want, if we want our conclusions based on a sample to be valid about the population, okay? Okay? The sample must be representative of the population. Okay, and when we say representative of the population, we mean that the sample looks like the population, at least in regards to this one aspect that we're interested in, okay? Representative means the sample looks like the population, okay? This is kind of the idea behind something like the House of Representatives in our government, is that the people in the House of Representatives are supposed to represent, you know, the people in their district. They're supposed to, you know, that one person is supposed to represent what the district looks like, and thus represent what the nation looks like. That, you know, whether it is effective at that, to that end, is questionable or debatable, because it turns out that the people who are elected in general have a lot more money than the people that they represent, and maybe also in general have more extreme political views than the people that they represent as well. So anyway, just in general, what we want is our sample to be representative or to look like the population. And if it is not representative, we might, the word we use to describe that is that we might have a biased sample, okay? A sample that is not representative may be called a biased sample, okay? Okay, it's really hard to get a representative sample. Okay. For anything, you know, on a big scale, probably the probably a lot of money is spent on election polling. I keep talking about elections because this is probably the biggest application of sampling, and it's hard, okay? A lot of money is spent on trying to get a representative sample so people can predict the outcomes of elections, and it's really hard to do, okay? And so people have made all sorts of efforts to try to get representative samples, and the truth is we still haven't figured out how to do it, okay? Probably one method people use is they just have a robot called random phone numbers, and by dialing a random number, and if somebody picks up, we're hoping that we can at least hit the population. But then, you know, you're only going to get people who actually answer the phone from some unidentified number, which will not be representative anymore, right? So if you think about who answers a call from a number that they've never seen before, it's going to be different from the people who avoid answering calls from numbers they've never seen before, right? And if one of your questions is, are you paranoid about calls from unknown callers, then your answers will all come back saying, no, I answered this phone, so I'm not paranoid, right? So you're not going to get something like that, but maybe, I don't know. Okay, so it's really hard to get a representative sample. One method that should give us a representative sample, it's not really guaranteed to, but one method that should is random sampling, okay? We call this simple random sampling, or SRS, okay? And we write should, we'll say not guaranteed to be representative. It should be, okay? Mathematically, in the long run, it should be representative, but it's not guaranteed to be, okay? And so simple random sampling begins with what we call a sampling frame. Okay, the sampling frame is going to be, ideally, the sampling frame is a list of everyone in the population. Okay, but getting a list of everyone in the population is really hard to do, okay? This list is hard to obtain. Okay. Next year will be 2020, and the US government will conduct a census where we try to get a list of every single person in the population. But this is hard to do. There's a lot of people that are hard to track down, people who don't have permanent addresses, and it's self-reported, right? And so if somebody is suspicious about the government, then they might not respond, okay? They might not answer. And if you put a question in there about citizenship, it might discourage even more people from responding. So it's really hard to get this list of everyone in the population, just because people are suspicious and don't want to answer the questions, and they don't even want to know that, they don't even want the government to know that they exist. So so this kind of stuff is hard, right? But let's say we do get a sampling frame, okay? Then in simple random sampling, we use a random system. Use a random system like and select individuals one at a time. Okay. I'll say from the sampling frame. Okay. And so when I say a random system, it could be as simple as writing everyone's name on a piece of paper and throwing it in a hat, and then shaking the hat and drawing a piece of paper out. Okay, that counts as a random system, and that works if your sampling frame is like 100 people, okay? Then you can write everyone's name. If your population has 100 people in it, it's possible to write everyone's name on a piece of paper and throw it in the hat, okay? Or, you know, I think the lotto is still done, like the big lotto is still done with ping pong balls or something, okay? And that counts as a random system. And the sampling frame or the population is however many numbers, 60 something numbers, and then you draw 6 numbers out or something. Okay, that counts as a random system. For anything bigger, we usually use a computer to help us generate random numbers, okay? And the advent of computerized randomness has really has dramatically changed things, and so we can generate lots of random samples very quickly, and the computerized randomness now powers slot machines in Vegas, and whatever. Okay, and so that's what we have. But again, if your sampling frame is biased, then your samples will be biased as well, right? So let's say you just wanted people in the city of Los Angeles. Let's say this is the population you're trying to chase, okay? For your sampling frame, you need a list of everyone in the city of Los Angeles, but how do you even get that list? I don't even know if that list doesn't exist by any government agency, okay? And I don't know what the closest thing would be to that. There's going to be a lot of people who don't have permanent addresses, okay? People that the city of Los Angeles does not know about. I imagine if you are a freshman or something, you just moved here a few days ago or weeks ago, the government probably doesn't even know that you are over here, okay? The only people that know you're here are your parents and your friends and the new people you've met. But anybody, and me, because you're on my roster, but trying to get some kind of sampling frame of everyone in LA, almost impossible, okay? But anyway, let's say we succeed. We get a sampling frame that's good, we get a simple random sample that's good. Then we've got a couple nice properties. I guess properties of SRS is that every individual has an equal chance of being selected. Okay, and every possible sample has an equal chance of being selected. Okay. So, and that's because we're selecting individuals one at a time. Every possible sample has an equal chance of being selected. And so that's kind of like the lotto. If you think of the lottery, let's say the winning ticket is, I don't know, 7, 25, 32, 33, 46, and 50 or something. Okay, I just made up some numbers. Okay, that ticket has an equal chance of being selected as the ticket 1, 2, 3, 4, 5, 6. Okay, every single random sample has an equal chance of being selected. Okay, and that's just how simple random sampling works. 1, 2, 3, 4, 5, 6 is not more or less likely than any other possible ticket that exists there. Okay. Let's see. We got to end at 11:50. I'm going to just keep going straight through. I know it's an hour and 50. Just hang in there. If you can sit 3 hours through Avengers, you can sit an hour 50 through my lecture. So. Okay, so next up we've got the nature of data. So in order for us to draw conclusions from data, we need data, okay? And so we'll gather data and we want to organize, the information we collect, okay? All right, so the nature of data. So we gather the data and then and we organize it. And I would say probably we often like to use a table. Use a data table, okay? And we might call this the tidy form of a table, but maybe kind of the preferred representation is that each row, each observation is in a row. Each observation is a row in the table. Okay, and kind of the flip side of that is that each row represents one and only one observation. Okay. And the second is that each piece of information that we gather is going to be a column, okay? So each piece of information or each variable is a column in the table. Okay. And different types of observations have to be kept in different tables, okay? Well, I won't even bother putting that. But basically, in one table, if you are keeping track of people and their test scores, and then in another table, you want to talk about classrooms, okay? Then you're going to need a different table, okay? You can't keep information about the classrooms in the same table as the information about the individual people, okay? So each column contains a variable. All right, so, you know, just some made-up data set, okay? So let's say we might get a sample of data, let's say a sample of students for data, okay? Okay, and so our table might look something like this. We might ask for their name, and we'll ask, you know, how old are you? And we'll ask their gender, and I don't know, your height, and hair color. I don't know. Okay, so yes. All right, and so we've got Alice, who is 20, is we'll say female, feminine, identifies, 64 inches, has brown hair, and we'll say Brett is 19, 71 inches, has black hair. Okay, I'm just making stuff up, okay? And you'll have basically one row per student. Okay, and so n is what we call our sample size. This is how many individuals we have, and this was going to be the same thing as the number of observations and it's the same as the number of rows in our table. So if you've got 40 rows in the table, then that means you have 40 individuals in your data, okay? We've got two kinds of variables, okay? Variables can be categorical or numeric. Here, actually, I'm going to go ahead and put this on the next slide. I'm going to just copy this part of the table. I'll save this. Okay, so I said variables can be categorical or numeric. Okay, so categorical variables, let me put this over here. Tell us what type or what kind. And numeric variables tell us how much or how many. Okay, so I think this is really easy, but what do we got here? So the name, this is categorical. We might call this an identifier. Okay, age, we'll say is numeric. Gender, we'll do categorical, okay, and allowing for more than 2 categories. We'll say height is numeric, and hair color we'll say is categorical, okay. Let's say I put in area code for their phone. And we've got, I don't know, 310 and 212. Okay? What kind of variable is area code? Yeah, area code is categorical. All right, it looks like a number, but it doesn't tell us how much or how many. It tells us what kind, which is a little bit weird, but basically it tells us like where you're, a little bit about your geographic location when you bought your phone, okay? And so, you know, there's, you know, no numeric meaning to the area code. Okay, it does not make sense. It does not make sense to say that Alice has 98 more area code than Brett, okay? I don't even know what that could possibly mean, right? So it doesn't make sense to kind of compare area codes in the way that you can compare heights. It makes sense to say Brett is 7 inches taller than Alice. That is a perfectly valid comparison. You can take numeric things and compare them, make a difference, calculate the difference, and that difference has meaning, okay? Talking about the difference in area code doesn't make sense, okay? You can say Alice is 1 year older than Brett. That's fine, okay? As far as hair color goes, if we just have brown and black, or let's say pink hair, okay, you cannot make some kind of, like, what do you get if you subtract brown hair from pink hair? Okay, there's no difference there. Okay, there's nothing there, right? I guess if we turned this into a black and white photo and then we were talking about like the I don't know, what do you call this, the pigmentation or something, and we have a numeric assignment to that, then we can turn a color variable into a number, which is how computers show pictures on the screen and stuff, and then you can talk about a difference there. But if we're just using regular old words and saying something like you've got red hair versus brown hair versus black hair or something like that, you can't take differences in those numbers, okay? So that's what we've got here. Let's see, is there anything else I need to say? Sometimes numeric variables can be turned into categorical variables. Okay, so age, if I ask you, how old are you? Okay, or if I say, what is your age? You will probably tell me a number, okay? Probably in years, okay? I guess you could say I'm, 9,000 days old or something like that, but people would say that's weird. Generally, we think of age as a number, but it can be made categorical, right? So legally, you can have minors versus adults, okay? And we'll say 18 is kind of the age of majority in the United States. At 18, you can open a bank account, enlist in the military, whatever, okay? Vote. And as far as, and if you're under 18, you can't do those things, okay? Or, I don't know, if you're like some marketing, okay? A marketing company might, so if you go on YouTube, they'll have different age categories, and they'll say this video is popular among 13 to 17-year-olds, okay? And this video is popular among 18 to 24-year-olds and 25 to, I don't know, 35 or 30, I don't know, something, okay? Different categories. I think it's like 25 to 40 or something like that, right? They do different age categories, and they segment the population this way, okay? Okay, or we talk about people being in different generations. This is, you've got, I don't even know what the names of the generations. You have boomers and Generation X and millennials, and what is the Gen Z? Is that I think they use letters and then change them into something that sounds better later, okay? So I think millennials used to be Gen Y, and then they changed it to millennials, and then I think it's currently Gen Z, but I'll probably change that to something else, okay? I don't know. I heard iGen being the generation that had access to smartphones since childhood, which, I don't know. Okay, anyway. Which has had significant impact on how our brains work. It's true, okay? Okay, so that's kind of organizing our data and keeping track of kind of what's categorical versus what's numeric. And then we have, we'll talk about gathering data. And I talked about this at the very beginning, and this is important, okay? All right, so we'll start off with anecdotal evidence, okay? This is what we all have, and it's our life story, okay? Our life story counts as anecdotal evidence, right? You experienced this in childhood, and you learned from those experiences, and that is the data that you have and has shaped your personality, right? So, depending on, what happened in your childhood, that has affected who you are today and has affected your personality. And so, so that's what we have, okay? We've got anecdotal evidence, and you can tell people, I remember this happening, and so I learned my lesson, and now I don't do this thing, or I do this thing now, stuff like that, okay? So the anecdotal evidence, this is, kind of like stories, okay? Other things that count as anecdotal evidence, again, I alluded to this. We talked about I know a friend who did this, and this is what happened. Customer reviews count as anecdotal evidence. Okay, so you go on Yelp to read about, I don't know, do people even use Yelp anymore?
Yeah.
They still do, okay. All right, Yelp is just anecdotal evidence, okay? It's just people talking about their experience at a restaurant, okay? Customer reviews on Amazon, right? I often, before I buy a product, I'll read reviews on Amazon and I'll decide, okay, people seem to like this thing, okay? But the truth is that from a statistical perspective, we cannot make conclusions from anecdotal evidence, okay? So, okay, I don't want to say that anecdotal evidence is worthless, because it's not. It's a billion-dollar industry, right? You got Yelp and all of these other customer review websites, and Yelp says we'll erase these bad reviews if you give us money, and stuff like that. So people profit off of anecdotal evidence, but from a statistical standpoint, it's difficult for us to really do much, okay? When you read these reviews on Amazon and this product has a 4.3 star rating and this one has a 4.6 star rating, I can't really tell you if the 4.6 product is any better than the 4.3 product, even if they're the same category, because I don't know who's writing reviews, right? There's a major problem right now of fake reviews being posted all the time. There's farms of people writing fake reviews for products they've never used and stuff, and people are trying to combat this, okay? You go on Rotten Tomatoes and the audience score for certain movies, especially if it's got a political flavor to it, often gets review bombed. Like there's like websites that take glee in mobilizing people into review bombing different things. It's hard, okay? So anecdotal evidence, even these customer reviews that we see online, from a statistical perspective, it's hard to really do much. And then again, all of your life stories have happened and have influenced who you are today, but then to generalize to the general population is also something we cannot do. We cannot say that just because this happened for you and this is how you experienced things, that other people in the population will, or even the general population will react the same way. There might be other people, other individuals who react similarly, but other individuals will experience the same thing and react a different way, okay? And so from a statistical perspective, it's difficult for us to make conclusions from anecdotal evidence, okay? Sometimes people will have an attitude of dismissing the anecdotal evidence, and I don't want to dismiss it. I just want to say statistically, we can't do much with it, okay? Okay, so as far as what we can work with statistically, we have observational studies. Okay. And with an observational study, we just observe our subjects, okay? We try not to interfere with our subjects, and ideally, the sample being observed is representative of this population. Okay, so we want a sample that is representative of the population. So we often employ random sampling, if possible. Okay. We try not to interfere. With subjects being studied. Okay, other than taking measurements, right? So if you have to do something like drawing blood to test for antibodies in their bloodstream, obviously you have to interfere with your subject's life. You have to pull blood out of them, which is only going to happen if you get their permission. And so we try, but other than that, we try not to interfere with the subjects being studied, okay? And ideally, we record as much information as possible. Record as much info as possible. And then we search for associations between variables that we've collected. Okay. And if we find such an association, we can say we have found an association, okay? But an association does not mean that one variable has a cause or effect, has a cause and effect relationship with another variable, okay? So we search for associations between variables we collect or collected, but in an observational study, an association does not mean an association or correlation between variables does not mean that there is a cause and effect relationship between variables. Okay. All right, so real life data, okay, so silly example. okay? We can study a bunch of households across the nation, and we will find an association between a child's reading performance in school and the number of electronic devices in the home, okay? Electronic devices. Okay, so I'm talking like TVs, tablets, computers, phones, and Alexa smart devices, and whatever. Okay, so if you count all of these electronic devices in the home, and you also measure a student's reading performance, there will be an association. Maybe not a super strong one, but there will be an association we'll learn what statistically significant is, and this will exist, okay? And what you will find is that homes that have more of these electronic devices will also have students that have better reading performance, okay? This is what we will truly observe in the data. Okay, so does that mean that having more of these electronic devices improves a student's reading performance? No. Okay, what do you suspect is the reason for us seeing this association? Yeah.
One thing is that like households that have more electronic devices also have like better or like are economically like well off, so they can afford like serious or something.
Okay, so we have, so you're saying households that have more electronic devices have more money, okay? And more money might be related to reading performance, okay? Does that feel like a better explanation? Okay, so some of you guys are nodding your head, but so then the question is, does more money mean better reading? More resources? Yeah, it's difficult, right? So somewhere along the way, it seems like the population or a lot of people have accepted this relationship between socioeconomic status and academic performance, and that they're generally, and of course for individuals it's different, but in general, families that have come from a way of means, meaning that they have money, have generally higher performing students academically, and families that struggle financially have less, the performance in schools or the students are lower. And the question is it money? Is it other things? And it's complicated, right? Life is complicated, right? Certainly having more money means, you have time to study versus your time is spent doing other things that that might be caused by financial things. Having money often puts you in districts where the schools are better funded, and there's more resources at that school to help students' academic performance and things like that. It is quite the relationship between everything at play is complicated. And so when we do an observational study, we're going to find these kinds of relationships, but it's also difficult to say that this is the reason why this is happening. Of course, we want everyone's reading and academic performance, especially at the elementary school age level, to improve. And how we go about this, if we can find the reasons for it, is a lot more difficult. And it's complicated. This is certainly money can help, but it also may not solve everything, because you can look at states across the nation and who spends the most on education versus academic performance, it's not completely aligned either, right? So in California, the public schools in California actually spend quite a bit of money. I mean, it's not the top, but it's not the lowest as far as per student spending. But the academic performance for individuals at California probably is not as high as what California would like it to be. So I don't know. I don't know what the answers are. It's hard. Okay. All right, and then the other part, and we've talked about this briefly, is on experiments, okay? Experiments, and we might call these controlled experiments. This is experiments or controlled experiments. Okay, and this is another method for gathering data. Okay, ideally, the researcher can control all aspects of variation. For the participants. Okay. The researcher will assign the treatments or a set of conditions to the subjects, okay? We'll say we'll randomly okay, and so here's kind of our ideal scenario. Okay, maybe you'll have two groups, group 1, group 2, okay? So subjects are randomly assigned to group 1 and group 2. Assigned to group 1 or group 2. Okay, and then we keep everything about both groups exactly the same, except for the treatment, okay? Okay, so we'll say, you know, group 1, maybe group 1 gets treatment 1, and group 2 gets treatment 2. Okay, and then at the end of the experiment, if there's any difference in the outcomes, we can attribute that difference in outcomes to the different treatments. To the different treatments. So we can say, you know, uh, with group 1 and group 2, you know, maybe you give everybody the exact same. So when I say like control everything, like you've got a bunch of subjects, then ideally, in the ideal scenario, and you probably can't do this with people, but you can do this with like mice and stuff, and you can give everybody, all the mice, like the same living environment, you know, have the same amount of lighting, the same amount of brightness, and the same amount of darkness. So like the same sleep cycles and the same food and the same water and all of this stuff. You keep everything the same. And then it's just in group 1, maybe you give them a certain drug, and then group 2 you don't give them the drug, okay? And then you can then see, you know, what effect does this have on the mice health or whatever. And if there's a difference between group 1 and group 2, then that difference, because everything else was the same, that difference can be attributed to the different treatments that we used, okay? It's a lot harder with people because people have freedoms, and you know, you can't, in the ideal scenario, we could say, all right, everyone's gonna get the same amount of sleep, everyone's gonna get the same diet, everyone's gonna have the same routine, they're gonna wake up at the same time, do the same exercise, do the same routine in life, and everything. Group 1 will get this treatment, and group 2 will get a different treatment. But obviously, that's generally not going to work with people, and so things get a little bit messier with people. Hopefully, the random assignment takes care of some of these differences, where, you know, in both groups you have about the same number of people who do this and the same number of people who do that. But yeah. A lot of experiments, however, are not ethically possible, okay? So, for example, you know, in California, we recently legalized kind of non-medicinal marijuana usage, okay? And there aren't very many studies studying the effects of marijuana usage on health, okay? We have observational studies, okay? But as far as experiments go, we don't have a lot, okay? And that's because it's not ethically possible. We cannot say, we cannot force people to start using marijuana and prohibit others from not using it, okay? Because people have a choice, right? As far as you know, a few decades ago, it was not known whether cigarettes were caused lung cancer, okay? There was certainly an association, okay? But the tobacco industry always came back and said, this is an association, but you cannot conclude. Hang on, you guys, I still got a few more minutes here, all right? So just be respectful, don't pack up yet. People said, just because there's an association does not mean that cigarettes are causing lung cancer. They said their reasoning was that these people were already predisposed to developing lung cancer. These people were going to develop lung cancer in life no matter what, and it's the same predisposition to developing lung cancer that also encourages them to start smoking or start doing something that will enter their lungs, okay? Now that seems kind of bizarre and strange, but it's also difficult to argue against if you haven't done a experiment where you have forced people to start smoking and then said, okay, let's check on your health in 20 years and see what 20 years of smoking has done to your lungs. That's not ethically possible, and so it was difficult to truly combat this line of reasoning. I do have to say that there's another kind of some newer work is being done in terms of drawing cause and effect conclusions from observational studies, and there's a professor here at UCLA who works in the computer science department who's written books on the subject. You can read it. It's called The Book of Why. by Judea Pearl. That's an interesting thing. But as far as this class goes, from a classical perspective, we are going to say you can only draw cause and effect conclusions from a controlled experiment and not from an observational study. This might change as time goes on, but this is where we are today. Okay, we'll end here for today. We'll see you guys on Wednesday, and